Assalamualaikum everyone. Today's episode is an enrichment lesson on refraction of light. We are applying one version of the Snell's law equation n1 over v2 equals n2 over v1. Just stick around, watch till the end of this video, and you'll definitely get something to learn. Here's the question. A man in a boat is looking straight down at a fish in the water directly beneath him. The fish is looking straight up at the man. They are equidistant from the air-water interface. To the man, the fish appears to be 2.0 meters beneath his eyes. To the fish, how far above its eyes does the man appear to be? As usual, these are the given data in this problem. The apparent position of the fish, denoted by h prime, is 2.0 meters. And the refractive index of the first medium, which is water, is 1.33. That index of refraction of water is denoted by n sub 1. We also have the refractive index of the second medium, which is air, denoted by n sub 2, that is equal to 1.00. The first medium is water because we are considering the fish as the object, and light rays or incident light rays will be coming from the object, all right, from the fish, that is, and will emerge to the second medium, which is the air. And our target variable is the actual position of the fish, denoted by small letter h. This is also the apparent position of the man as seen by the fish. Alright? So the apparent position of the man relative to the fish is in fact what the question is looking for. Moving on with our solution, in this situation, the water surface acts as a plane refracting surface, forming a virtual image of the fish. Alright? And we stated earlier that the first medium is water. Alright? Where the incident ray or rays will be coming from the object or the fish. Alright? So these light rays strikes the surface or the water-air interface and emerges towards the man's eyes. Alright? So, strictly speaking, there is no what we call refraction occurring in this situation because the incident rays, alright, is perfectly aligned with the normal line. In other words, there is no angle of incidence or the angle formed between the incident ray and the normal line. Alright? We know that refraction literally means the bending of a light ray as it moves from one medium to another medium. Alright? So strictly speaking, we cannot call this refraction. But there is definitely a change in the speed of the light as it moves from the water to the air. Alright? And since water is optically denser than air, we say that the speed of light in the water is in fact less than the speed of light when it is traveling in air. Alright. Now, one version of the Snell's law equation, alright, which is N1 over V2 plus N2 over V1 must be equal to 0. Alright? So this is interpreted as the ratio of the index of refraction, alright, of the first medium divided by the speed of light in the second medium plus the index of refraction of the second medium over the speed of light in the first medium, right, is equal to 0. Now, this equation can be modified to this form: n1 over h plus n2 over h prime equal to 0, alright, so that the equation will be appropriate to the symbols of the quantities that we have defined earlier. Alright? So in this equation now, n1 over h plus n2 over h prime equals 0, we say that h, alright, is the object distance. And h prime is the image distance. And our working formula to calculate for h, or the actual position of the fish, will be h is equal to negative h prime multiplied by the ratio of n1 over n2. Alright? Take note, upon transposing n2 over h prime to the other side of the equation, right, we put a negative sign. So that is why we have here indicated a negative sign, okay, for the right side of this working formula. Executing our working equation, we find that h is equal to negative h prime multiplied with the ratio of n1 over n2, right? Or h is equal to negative, alright, quantity negative 2.0 meter. H prime, alright, is negative because the image is a virtual image. Alright? So in short, we have a double negative in this equation. All right. And that will be multiplied by the ratio of n1 over n2, or 1.33 divided by 1.00. So doing our math, we will get the value for each equal to positive 2.7 meters. All right. As expected, the object distance, or h, is positive. All right. So this computed actual position of the fish is in fact also is equal to the apparent position of the man when seen by the fish. And we can check that in just a very short while. Using the same modified Snell's law equation, h equal to negative h prime multiplied by the ratio n1 over n2, where h prime is now the apparent position of the man as seen by the fish, and h is the actual position of the man. Likewise, the first medium is now the air. All right? The incident rays from the object or the man strikes the air-water interface, and this light ray enters the second medium, or water, all right, and reaches the eye of the fish, all right, the fish being the observer. So solving for each, we get h equal to negative quantity, negative 2.7 meters, all right. Negative 2.7 meters is the apparent position of the man, all right, as seen by the fish. That is to be multiplied by n1, or 1.00, divided by n2, or 1.33. So doing our math again, we will get the value for h, or the actual position of the man, equal to 2.0 meter. All right. So you will notice that the computed h equal to 2.0 meter, all right, was actually the apparent position of the fish, okay, when observed by the man. But this time, this value is actually the actual position of the man as seen, relative to the fish. All right. The fish observes the position of the man being equal to 2.7 meters. All right. But the actual position of the man, all right, is in fact equal to 2.0 meters. All right. So before we end, let's emphasize here the key concept that we applied in this problem. We say that a plane refracting surface always forms a virtual image. An object on the other side of the refracting surface appears to be at a different distance from the surface than its actual distance. So that concludes our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.